And today we're going to talk about the actual formation of urine. So I assume most of you know your kidneys are important in making urine. Most of you are aware that you need to go to the bathroom, but how exactly does that urine form? Where does it come from? What does this filtering do? So urine formation involves that glomerular filtration, tubular reabsorption, and then tubular secretion. So we're going to filter, we're going to reabsorb stuff, and then we're going to secrete stuff. So glomerular filtration is the first step. So urine formation begins when the fluid part of your blood is filtered. So the glomerulus, that nephron with the blood vessels around it, the glomerulus is filtered, or does the filtering, and then it enters the glomerular capsule as the filtrate. So basically it takes your blood and it takes the liquid part of it, it filters that, it goes through the glomerulus, and then this filtrate is what is left. Produces about 180 liters of fluid per day. Lucky for us, we don't get rid of all of that. So 180 liters of fluid a day. Most is returned to the blood during the process of reabsorption. So even though all of that is filtered, you don't get rid of all of it. A lot of it is reabsorbed. The last step then, tubular secretion, moves additional substances from the blood into the tubule to get rid of some of these other things that aren't really part of the liquid part. So as that happens, water and certain dissolved substances are filtered out of the capillaries, and then they're captured in this capsule, is basically where they're stored or captured at. The glomerular capillaries have many fenestrations, many little parts to it that allow more filtration than other capillaries. So you have capillaries throughout your body, and your oxygen diffusion happens through all of these capillaries. Your glomerular capillaries have, and I don't care if you remember fenestrations, it's not on your test, but I want you to know that those capillaries do a better job of filtering, I guess is what I want you to know. Cells called podocytes help prevent plasma proteins from being filtered out. Your plasma proteins we don't want leaving the body, so podocytes make sure that they stay with your plasma. And then the glomerular filtrate, so what's filtrated out of your blood, mostly water, your urine is mostly water, electrolytes or salts, glucose, some sugar, urea, which gives it the smell, and then some uric acid. So those are the main things that are going to be put or part of your urine. So here, basically, we've kind of looked at this picture before. So here, my nephrons are inside of here. That's where the filtration takes place. This glomerular filtration includes all of these capillaries that are very important for filtering. Remember, afferent comes in, efferent is going to leave. And then this filtered fluid, so here's the blood supply. The fluid that is filtered out is then going to go along this tube and called tubular fluid. Some of this fluid is going to go back into your blood system. And then here, tubular secretion is where some of those small particles from your bloodstream enter into your tubular fluid and becomes urine. Down here at the bottom, this is pretty much your renal tubule, is where that fluid goes through. Just another picture. The only thing I really want to point out here, podocytes are scattered throughout to make sure the good stuff does not leave your blood supply. You can see the capillary endothelium. There are these openings where larger particles can pass through. And there's those fenestrations. Fenestrae are used for filtering. So here you can kind of see how much stuff is used. So if I'm looking at the numbers, sodium is big, chlorine or chloride is big, sulfates and phosphates are large, and also potassium. But you can kind of look and see what type of substances, so these would be your electrolytes that are going to be put into your urine. These are electrolytes. And then here's your sugar or glucose, urea, and uric acid. And notice urea has a large part that goes through. Pressure, the main force responsible for moving things through the glomerular capsule, through the capillaries, is hydrostatic pressure or osmotic pressure. It's the pressure of water, how much water is there. The net pressure forcing substances out is the net filtration pressure, and that should always be positive. So basically, you are always forming small amounts of urine. The smaller diameter of the efferent arteriole compared to the afferent arteriole raises the blood pressure in the glomerulus, and that favors filtration. And that's kind of back to the question about blood pressure. The amount of water or the pressure that's inside of your glomerulus, inside of your kidneys, also kind of helps to dictate your blood pressure. So due to plasma proteins, osmotic pressure, hydrostatic pressure, basically some of these things are going to add to resisting filtration. However, the diameter is going to make it so that it always favors filtration. Here it just shows a picture of the force. So you can see the hydrostatic force coming out is large, going in is smaller. So net filtration, typically an outward movement. We're going to filter and send things outward. Rate of filtration. The factors that affect filtration are pressure, osmotic pressure, hydrostatic pressure. Basically, it's that pressure differences that are going to affect the filtration rate. When the afferent arteriole constricts, it's going to slow down the filtration rate. When the efferent arteriole constricts, then it's going to increase the rate of filtration. And think about it, when you drink a lot of water, drink a lot of pop, drink a lot of fluids, obviously you're going to put more water into your bloodstream, which is going to cause more pressure, which is going to increase the rate of filtration. If the osmotic pressure inside the glomerular plasma is high, filtration rate will decrease. 5, I'm not so concerned with. 6, on average, filtration rate is 125 milliliters per minute. So when you think about, your kidneys are very, very active. So when people have kidney failure, that is a big deal. Like we said, most of it is reabsorbed, but your blood still has to be filtered. Even if it doesn't get rid of everything, your blood has to be filtered. And 180 liters is a lot. You know, you think of a 2-liter bottle, your blood is being filtered constantly. So you think of how hard your heart works, pumping constantly. your kidneys are really very similar to that in the amount of work that they do constantly. I think a lot of people don't realize that amount that goes through their kidneys. The filtration rate is fairly constant. I would like you to know that. It remains fairly constant, although different impulses may cause it to change a little bit. The size of the arterioles are going to be very important, and that's probably, and blood volume. And like I said there, the amount that you drink during the day makes a big difference on your blood volume. Another control over filtration rate is renin-angiotensin system, and that's going to regulate sodium excretion. So what I basically want you to know here is salt is huge in how your kidneys work and how much they function. So what happens, this juxtaglomerular cells will secrete renin in response to three things. One, a drop in blood pressure, so if your blood pressure drops. Two, sympathetic stimulation from your brain, so this is going to come from your brain. And then three, that macula densa cells are going to pick up or sense a decrease in your important salt ions. So sodium, chlorine, there's also potassium chloride, so that's why both of them are together. And they are going to pick up the difference there. And then I think I'll stop for just a minute.